Hello, and welcome back from spring break to our Physics 231 class, now online. As you know, we are going to be doing our lecture class online for the next 2 weeks, and I am going to be presenting our lectures in a recorded format and posting those online so that you can look at them and run through them at your leisure, pause them, play them back, and they will be available for you to look at whenever you'd like. Well, I hope you haven't forgotten everything we talked about before spring break, like Newton's second law of motion or the definition of acceleration. To review, I'd like to do a quick example of Newton's laws of motion and the circular motion that we were doing right before spring break. So let me ask you this question. What force keeps a car on the road when it's going around a curve? What's the force that keeps it from sliding off the road, basically? That force is static friction. So let's consider a car rounding a curve. Here we have a car that's rounding a curve that has a radius of 150 meters. And let's assume that the coefficient of static friction between the tires and the road is 0.8. What we want to do is find the maximum safe velocity that that car can have and not slide off the road. So we will apply Newton's second law of motion. Sum of the centripetal forces equals mass times centripetal acceleration. We just said that centripetal force is the static friction force. So we put static friction in, remembering that centripetal acceleration is also the speed squared divided by the radius of the curve, and that static friction is the coefficient times the normal force, and this is what we're left with. Well, we need to find the normal force, and we can do that from Newton's second law of motion. If we apply Newton's second law of motion to the car in the vertical direction, we find that the normal force has the same magnitude as the weight, or mg, and so we will substitute that for n in our equation. Then we find that since there's mass on both sides, it divides out. And now let's solve for the velocity. What we find is that the velocity does not depend on the mass of the vehicle. And this ought to make a little sense to you, because if you have ever been on the interstate and taken an exit that was a circular off-ramp, you know that there's a sign on that circular off-ramp telling you what the maximum safe speed is. And it might be 25 miles per hour. It does not say 25 miles per hour for a Cooper Mini and 20 miles per hour for a Chevy Suburban and 15 miles an hour for a semi-truck. The mass of the vehicle does not determine the safe speed, and that's why there's only one speed posted, because it doesn't matter what vehicle we're talking about. So let's go ahead and put in our numbers and see what we get. So the maximum safe velocity that any vehicle could have rounding the particular curve that we're talking about is 34.3 meters per second.